already know how to do currently. Okay, we don't know partial fractions yet, but there are certain things that we already know how to do. First of all, it is to learn how to combine two fractions together, or in other words, mathematically, it's about adding two fractions together or subtracting two fractions together. So in this example over here, 1 over x plus 1 over x plus 2, what do we usually do when we deal with such a fraction?
Make the denominator the same.
Make the denominator the same, right? And the denominator that we want shall be
X times x plus 2.
x times x plus 2, okay? So numerator in this case will be 1 times x plus 2, okay? And then, oops, I hope that you all can see, okay? Then after that, on the other fraction, I also have x times x plus 2, right? So over here, I will times x, okay? Then now I have the same denominator already, I can combine it into a single fraction of a denominator x times x plus 2, and then I will get x plus 2 plus x on the numerator, right? Then, okay, what do we do next? I think this screen got a bit of problem, right? It's a bit lagging, okay? So do pardon that. Okay, so in the numerator we can simplify it further. We will get 2x plus 2 over x times x plus 2, right? So this is what we know how to do since set 2 last year. Okay, we know how to combine two fractions together. The same method will apply even if it's for subtraction. So if it were to be a minus sign, okay, over here for example, the method will apply. Just that we have to be careful in terms of how we simplify it. Okay? But this is not what we're going to learn today. What we're going to learn today is how do we actually move from here to here. So if I were to give you this, okay, how am I going to split it into two separate fractions? Or sometimes maybe three separate fractions, okay? Essentially, we want it into separate fractions. That's why it's called partial fractions, okay? Please let me know if you need some time to copy before I move on. I think this one don't really need to copy since it's something we already learned, okay? I'll move on. Okay, so as I mentioned, what we want to know today is how to do the reverse process. Okay, so I have mentioned this earlier already. That's our objective, right? Because if I don't know what is this going to look like, there's no way for me to go from here to here. Okay, so we need some guidance, right? So in order to do that, okay, we need to have some sensing over the denominator. Okay, so the first thing regarding partial fraction is that we must know it depends on the denominator of the fraction. So over here, I have shown you three different types of denominators. Okay, some examples. The numerator itself, I'm just representing it with a star because it really doesn't matter. The impact is more on the denominator itself. So I've indicated here the first type of fraction where in the denominator I have x plus 1 and 2x plus 3. Okay? So what kind of denominators are they? Okay, they are linear factors. Okay? You know what is a linear factor? Okay, a linear one is when it is a power of 1. It is a degree 1 polynomial. Oops, sorry. It is a degree, laggy. Okay? It is a degree 1 polynomial. Okay, the highest power is 1. Okay, so when it is linear, okay, how will the partial fractions look like? Okay, the partial fractions will look like having one that is over x plus 1, the other one 2x plus 3. We are always assuming that it is an addition. It may change into a subtraction when the numbers that you find later on for a and b are negative. Okay, so a and b are just numbers that we will have to find out later on. So you've got to remember that when I have linear factors, okay, when you have linear factors, this is what we will get as two separate fractions. Okay? Then, shifting up a little. Okay, second type, right? We have in the denominator 2x plus 3 and x minus 5 squared. Okay, 2x plus 3 is linear. Okay, x minus 5 bracket square, it is quadratic. Okay, but I want us to recognize it as a repeated linear. Okay, why do I call it repeated linear? It is because x minus 5 itself is linear. And then when you repeat the multiplication by having x minus 5 squared, which means x minus 5 times x minus 5, it is repeated. That's why it's called repeated linear. Okay? So what if our denominator were to be this way? Okay? So with the 2x plus 3 denominator, it causes us to be able to get a fraction that looks like this. Okay? Then after that, if I have a repeated linear, it actually generates for us two fractions. One is b over x minus 5. Okay? The other is c over x minus 5 squared. Okay? So just to draw that distinction, earlier on, when I have this one linear, it gave me this fraction. Okay? And then 2x plus 3 here gave me the other second linear fraction. I hope the color can be seen. Let me try to darken it. Okay? Right? So I'm just getting the concepts down first. Okay? Knowing what is the format, okay, that will be created first. Alright? Yes, go. Yeah.
Why is it square?
Why is it square? I mean, this is just the way it is. Yeah. So this one you have to just accept it. Okay? Yes, you gotta just memorize it. Okay?
So even like smaller than x plus 5 also has to be square.
X plus 5, yeah. Okay, so later on I'll give some examples. Don't worry, okay? Oops. Let me just erase it, Okay? Shall I move on? Okay. Third type. Okay, what do we observe here in the denominator? We will observe that x minus 8 is actually a linear. Okay? Oops. Okay, and then for the x squared plus 4, okay, it is clearly quadratic. Okay, the highest power is x squared. Okay, and this x squared plus 4 cannot factorize anymore. Correct? X squared plus 4 cannot be factorized now. It is not your x squared, your a squared minus b squared. So, can no longer be factorized and it is strictly just quadratic. Okay? Right? So what this has created for us is that from the linear, I'm able to get this fraction here, a over x minus 8. And then from the quadratic, the one that cannot factorize, I really need to emphasize on the fact that it cannot be further factorized. Okay? I'm able to get a single fraction. Okay? And something I want us to be able to observe is that the numerator looks different. Okay, so earlier on, when we had our repeated linear, we generated two fractions of which b and c are just some numbers, they are constants that we need to find later on. Okay, whereas for quadratic and cannot factorize, okay, our thing on the numerator is a linear expression of the form bx plus c. Okay, take note a, b and c are just some representations. You can use other letters. Okay, but in convention and from the textbook how you see it, they will use capital letters, okay, to represent these constants. Okay, so a, b and c are just constant numbers. Okay, so they are to be determined later on. Right? So over here, these are just some examples. I have made use of some numbers, certain specific expression. Of course, you are not going to encounter all the time x plus 1, 2x plus 3 as your denominator or x minus 5 bracket squared. These are just very specific ones. Okay, I just need us to recognize linear, Okay, repeated linear as well as quadratic cannot factorize. So the three main types are actually, okay, type 1, okay, if I scroll down a little, okay, type 1 is about how to deal with linear. Type 2 is about how to deal with repeated linear. Okay, and type 3 is about how to deal with quadratic that cannot factorize. Okay, so that is the lesson that I want us to learn, okay, regarding this segment over here. Okay, shall I move on to an example?
Yes.
Okay. Okay, before I move on to an example, unfortunately, okay, I have to say that the denominator is not the only consideration. We need to check if the fraction is proper or improper at the start. So the fraction must first be proper before we are able to break it down into its partial fractions. Okay, likewise, I'll show you an example, okay, regarding improper fractions. We'll start off with examples that are proper fractions first. Okay. But first we need to make sure we understand what is proper fraction and improper fraction. Okay, give me an example of a proper fraction.
3 over 5.
3 over 5. Right? Okay, any other example? 5 over 3.
That's improper.
That's improper. Okay, 5 over 3 is improper. Okay, so even if having mixed number, we also call it as improper. Right? Okay, so and 1 and 2 over 7 is improper because if I write it into a fraction, okay, I will be having 9 over 7. Okay, so another example of a proper fraction may be 2 over 7. Okay, of course you can have negative proper fractions and negative improper fractions, but I don't want to bother us with negative numbers here. Let me shift this. Okay, so now that we understand what is a proper and improper in numeric form, what does it mean in the algebraic form? Because we're all dealing with algebraic fractions now. Okay, so I want us to see that improper fractions, right? What makes it proper? What is the number? How do I compare the number in the numerator and the denominator?
Numerator is less than the denominator.
Okay, numerator is smaller than the denominator. Okay, so numerator is smaller than denominator. I'm writing it in short form, DEN for denominator. Okay, and then for improper fraction, it is improper because the numerator is larger than denominator. Okay, so how do I have this same understanding to be applied to an algebraic fraction? Right? Because if it's in algebra, right? Okay, Miss Low is here. Can someone open the door for her? Okay, and that's Miss Low. Right? So, how do we determine that? Okay, for algebraic fraction. Okay, attention over here. Right? So, for algebraic fraction, right? Okay, we look at the degree of the polynomial. Okay, because if it's an expression x plus 1, I will never know is it going to end up becoming bigger or smaller than another expression. Okay, sometimes. Alright, so for proper fraction, okay, proper algebraic fraction, we can have things like, maybe I'll choose a purple. Okay, I can have, for example, maybe 3x plus 1 over 5x squared minus 3x plus 6. Okay, so this makes it proper, and the reason is because over here it is a degree 1 polynomial, and over here it is a degree 2 polynomial. Right? I hope you recall what is considered a degree. So, in case you have forgotten, degree is regarding the highest power of x found in that polynomial. So, in this case, 3x is the highest, the power x, okay, let me repeat myself. The power, okay, of that particular x term is 1, okay, and then the highest power of x found inside this polynomial is 2. Okay, so that's why the denominator has degree 2 and then numerator has degree 1. Okay, then in contrast, What about improper algebraic fraction?
When you flip,
Okay. Yes, maybe I can have the flip like what Moses has suggested. 5x squared minus 3x plus 6 over 3x plus 1. Where we see now that in the numerator we have degree 2 and in the denominator we have degree 1. Okay? Alright, so I hope we are clear about what is considered proper and what is considered improper. Okay? So hold that in your mind first or hold it in your notebook. Okay, we are going to go into improper later on. Okay, maybe not today. Alright? Let's do one question type first. Okay? Oops. Sorry, let me get my own answers out first. Okay, we look at exercise 4.4 question 1a. This is considered type 1. Oops. Okay, ready? Shall we start? Okay, so express 3x plus 1 over x minus 2 times x plus 5 in partial fractions. Okay, the first step that we always have to do is to check whether is it proper or improper. Okay, but I'm telling you now that the questions we're going to start off with, they are all proper. Okay, so I'm just going to write down in red what are the steps that you need to usually go through. I'll just go at step 0, okay, that we need to check. Oops. If it's proper or improper. Right, so in this case it is proper because down here is degree 1. And down here, if you were to expand it, it will become quadratic. Okay, we don't need to go and expand it. Okay, we must know that when I have these two things multiplying each other, it will surely expand out to become quadratic because you will have x times x when you do a rainbow method. So it will surely be a degree 2. Okay, so requires some observation. Right? Then we can jump into our step 1. Okay? Which is to, based on the denominator, we separate out into its fractions first. Okay, separate into its partial fractions. What do I mean by that? Okay, so based on what we understood earlier on, with it being type 1, I can say now that 3x plus 1 over x minus 2 times x plus 5 is equals to a over x minus 2 plus b over x plus 5. I don't know what is a and b, which explains why just now I said I need to go and find a and b, which I'll teach you in a moment. Okay, so this is the first step you must do. Okay, and why is it that it is going to split out into these two fractions? It is because the denominator are both linear. Okay, so x minus 2 will give me this, and then my x plus 5 will give me this. And we always put a plus. Okay. Then step 2. Okay, we will need to go and find out what are the values of a and b. Or just the constants now. Okay, we need to find the values of the unknown constants. And this is the part where we are going to try to recall our chapter 4.1. where we learn how to substitute suitable values, okay, or what is the other method, or do comparing of coefficients. Okay, so how do we do that? So this is the main bulk of solving partial fractions. Okay, first thing, can I get an agreement that if I have three, I'm just rewriting what I just wrote. Okay, can we have an agreement that if I were to multiply both sides, okay, alright, both sides, okay, by x minus 2 and x plus 5, okay, which is the denominator of this original fraction, okay, multiply both sides, because I need to balance the equation, right? I cannot just multiply one side. Okay, what happens when I do that? I will be able to get 3x plus 1 on the left, and then on the right, okay, with this fraction over here, multiplying with the x minus 2 and x plus 5, I will be able to get a times x plus 5. And then for the second fraction, okay, over here, I'm able to say b times x minus 2. Can I get your agreement that this is true? Okay, the reason in case you don't understand, okay, I'll just use a green marker, green pen, okay, it's because it's like cancelling, right? Because over here I can cancel out, right? And then I'll be left with 3x plus 1, okay? And then after that, for the fraction individually, I multiply individually, okay? Because it must be everything together on the right side that gets multiplied by the same thing. That is the idea of balancing an equation. So I can cancel this with this. That's why I get a times x plus 5. Right? And then looking at the second fraction, let me undo. Okay. Second fraction, the green one on the right, I can cancel this with this. That's why I get a b times x minus 2. Okay? So that is the strategy. Okay? Because I think we don't like to deal with solving fractions. Fractions are a little bit troublesome sometimes. So we want to make it linear, okay? A single line, don't have any denominators, much easier for us to solve. Right? So we can do that to an equation by multiplying on both sides with the main denominator here. Okay, this main denominator. Right? Then now that we have this, remember our objective is to find the values of the unknown constants a and b. Okay, so I want to find out the value of a, and I also want to find out the value of b. Okay? How can I do that? Right? So in chapter 4.1, okay, we had two methods that are possible. Okay? One method is by comparing coefficients. Another method, it will be by substituting suitable values. Okay? So, to compare coefficient, that may sometimes require us to expand everything. Okay? Which sometimes we might make careless mistakes. Right? So, may not be the best way to actually do this question. In fact, there's an easier way, I feel, personally, which is to substitute suitable values. What do I mean by that? Okay? When I say to substitute in x equals to negative 5, okay, what happens? Why did I choose negative 5? It is because I observe here that there is a x plus 5. Right? What happens when x is negative 5? Negative 5 plus 5 becomes 0. So it is a strategy. Okay? I don't anyhow pick a number randomly, okay, from thin air and then substitute in. Right? So I choose to let x equals to negative 5 to make x plus 5 0 so that I can find the value of b. There is no order required. You can find a first, b first, c first, or you can find others first. Okay? Just go for the most tackle the easiest one first. Okay? So in this case, I decided to go and find the value of b first. by substituting x equals to negative 5, then on the left, I will have 3 times negative 5 plus 1 equals to, this becomes 0 already. On the b times x minus 2, I'll get b times negative 5 minus 2. Right? And what will that give us on the left? Negative 15 plus 1, that is negative 14. And on the right, I will have b times negative 7. Okay, I'll scroll up. So I can now say that b is equals to negative 14 divided by negative 7. So that is equals to 2. Okay. Personally, I will prefer to do substitution of suitable values first. Okay. Then when I really cannot do it anymore, I will do the comparing coefficient. So my priority in my choice of method, maybe I'll rename this is number 1 to me. Number 2 is comparing coefficients. Okay? Because creating 0 is easy to make calculation much easier. Right? Then, now that I found the value of b already, I will find the value of a. Okay, so remember to find the value of b, I made x plus 5 that was together with a 0. Now, I do a different approach. Okay, I try to make x minus 2 0 so that I can ignore b entirely. I don't need to consider b in my calculations already. Okay, so what should I choose for my x? 2, right? Okay, so when x is equals to 2, I'm going to get 3 times 2 plus 1 equals to a times 2 plus 5, and then b will become 0 already because x minus 2 is going to be 0. So now I will have 7 equals to a times 7. So a will be 7 divided by 7, which is 1. Let me create a new page. Okay? Right? I hear a lot of buzz. Just want to check any questions that I may want to take, I may need to take. Okay? So, now that we have found A and B already, what is the objective of the question? Was the question asking us to find A and B? No, Question, remember, is asking us to express that into partial fractions. So we have not yet answered the question. So, you need to remember that we got to answer the question. Okay, remember to answer the question. And therefore, the answer will be 3x plus 1 over x minus 2, x plus 5 equals to a over x minus 2, right? So it will be 1 over x minus 2 plus b will be 2, and then denominator is x plus 5. Okay? So this will be the answer. Okay? Alright? Let's move on. Okay, moving on to another question. Looking at try 19 on page 87. We have 3x plus 5 over x squared plus 3x plus 2, and we want to express that into partial fractions. Okay? And we may have a little bit of a problem. Like I mentioned, this is proper. Okay, these examples are all proper. Okay, the problem here is our denominator. What is it? It's quadratic, right? But does it fit into the mold that I gave you all just now? If I were to scroll up,
Yeah.
okay. Remember this thing about type 3? I said that it is quadratic, but I place emphasis on it cannot factorize. Okay? So, if it can be factorized, then how? Because that should be a natural question, right? You can factorize how? Okay? I factorize, and then what should it become? Become a linear. Okay, linear situation already, your type 1 situation. Right? So we got to factorize it. So for your quadratic expression to factorize, we should be doing our cross method. But of course, if you're highly competent in doing your factorization quickly, you can easily get your x plus 2 and x plus 1 in the denominator.
Yeah.
Okay? So now that we have done the factorization, it still is our type 1, whereby we have linear factors. Oops, that's my eraser. Okay, I still have my linear x plus 2 and linear x plus 1. Okay, so what does that break out into? It gives me a over x plus 2 plus b over x plus 1. Alright, I'm just going to fill out on the left side that this is what we're dealing with. Okay. Right. Then from here how? Okay. Same method applies. Okay. We multiply both sides by the largest denominator, which is your x plus 2, x plus 1. Okay. I'm writing it in red because you don't really need to write this out. Once you get the idea, you can immediately jump to writing this statement that I'm writing in blue now. Okay? Yeah. Okay, so multiply both sides. Okay. Then, now from here, we find the value of A and B. So what should I let? What should I use? So I mentioned we use our substitution method first, right? What is the value that you want? Negative 1. Okay, sure. When x is negative 1, on the left side, I will get this. Then over here is 0, because negative 1 plus 1 is 0. 0 times anything is 0. Then plus b times negative 1 plus 2. Okay? So now I will have 2 here. Okay, equals to 1 plus 1 times b, so it's just b. So b is equals to 2. Okay? Then, what is the value that you want to choose to find out the value of A?
Negative 2.
Negative 2. So I will have 3 times negative 2 plus 5 equals to A times negative 2 plus 1 plus 0. So I'll scroll up higher. Okay, I will be able to get negative 1 equals to negative A. So A equals to 1. And therefore, answer the question. Our original question was 3x plus 5 over x squared plus 3x plus 2 equals to a is 1 over x plus 2 plus b, which is 2 over x plus 1. Okay, so I get this as my answer. Okay, questions? Right, Michael? Yeah, time. Okay, maybe it's slow answer question. Okay, I'm mindful of time, so I will not give you all time to do a little bit of practice, but okay, I would like us to all take note of this question 1D. I want everyone to go back home and try it in your notebook. Okay, so for 304, your next relief teacher will go through this question. Okay, and then 301, when I see you next week, I will go through this question. Okay, so go back home and try question 1D on your own. Okay, go home, try. Okay, not try now. Alright, so let's look at type 2, try 20. Okay, so go home, try question 1D. Alright, ready to start try 20? Type 2, Okay, can I have the attention over here on me? Now let's look at this. We have 5x squared minus 6x minus 13 over x plus 3 times x minus 2 squared. What is the denominator that we have? We have one linear, and more importantly, the next one I have x minus 2 squared, which is a repeated linear. Right? So, therefore, based on what we learned about breaking it into partial fractions, my x plus 3 denominator will give me a over x plus 3, while my repeated linear denominator will give me b over x minus 2 plus c over x minus 2 squared. Okay? Right? So I'm getting 3 fractions now. Okay? So same method applies. We don't like to deal with fractions. We need to strategically multiply across on both sides by the same thing, by the largest denominator, and that is x plus 3 times x minus 2 squared. Okay? So I am going to get 5x squared minus 6x minus 13 on the left side, and on the right side, okay, maybe for you to visualize better, I'm going to write down what I multiply over here. Okay, so let's see what am I going to get for the one that I boxed up in yellow for the fraction. When I multiply by x plus 3 times x minus 2 bracket square, I will get a times x minus 2 squared. You think about cancelling, x plus 3, x plus 3. Okay? I remove the cancellation to move on to the second fraction. For b over x minus 2, I only have a single x minus 2, so I can only remove a single x minus 2. Therefore, I'm going to have plus b times x plus 3, x minus 2. Okay, so slightly different from what we saw earlier. Okay, regarding the b. And then for c, okay, for c, I'm going to remove or cancel away x minus 2 squared, x minus 2 squared. Okay, so I will be able to get, let me just cancel neatly. I will get plus c times x plus 3. Alright? Okay, so this is what we get. Ready for the next step? Okay, ready? If you're ready, could you please button down? Now, remember I said that I always like to prioritize substitution of suitable values. Correct? Can I get your attention? Alright, substitution of suitable values. Okay, so in this case, what would I want to substitute in order to find out what is the value of A, B, or C? Doesn't matter which one we start off with first. Okay, so maybe let's try to find out the value of A first. What will you substitute to find out the value of A?
2.
If you substitute x to be 2, then your A is 0 already, what? Because A times 0, ma. So we should choose we should choose x to be negative 3. Right? I'm trying to find A, I'm just intentionally putting in the zeros here. Okay, so this one becomes 0, this one becomes 0. Okay, so that's why I get 0 here and 0 here. Okay? Because you don't need to care what is the value of B. Because once you multiply with 0, it will surely be 0. Okay, in case you don't know that. Alright? So that's why I'm choosing x to be negative 3 to help me find the value of A. Okay? Then use your calculator to help you in calculation. Okay? So, I will be able to get 50 on the left side. And then on the right side, it will be negative 5 bracket square. That is 25A. So we have found A to be 2. Okay? Give you a moment to think about what you're writing. Moving on. Let's move on. Any major questions that I need to address before I go on to find the remaining values? Okay, let's find the value of B or C. Okay, C will be next easiest one to find. Okay, so to find the value of C, we will now choose x to be equals to 2. Okay. So I'm going to have 0 here plus 0 plus C times 2 plus 3. Okay, like that. Oops, sorry, I've got an extra bracket here, you see? Yes. This will give me negative 5 on the left hand side equals to 5C on the right hand side. So C is equals to negative 5 divided by 5, that will be negative 1. Okay? Right? So now that we have found A, we also found C already. How to find B? Let me zoom out for us to see our overall working. Okay? So what do we see? Found A and C already. Is there a way for me to substitute a suitable value to find B? No way, right? Because when I substitute in -3, my B disappears, becomes 0. Okay, when I substitute in x equals to 2, my B also disappears, becomes 0. Alright, so we need to find out another way, okay, to actually find out the value of B. Now there are two options. Either you just substitute in another value that is not -3 or 2. That is one option. Or you expand everything and compare coefficient. But I hope that I can get an agreement by doing expansion. It may not be the most efficient. Troublesome, right? Okay, to do expansion. Okay, so we will choose to do substitution of suitable value also. But in this case, your value can be anything. Okay, let me create another page. Alright, so you want to choose 1 million also can. Just that it's ridiculous. Alright, the easiest number to choose is 0 or 1. Okay, so let's go with 0. Right? So then on the left hand side, you can easily tell that it's -13. Because once it times x, it becomes 0. When you choose x to be 0. Okay? On the right hand side, sorry, it's not visible on the screen here. But then on the right hand side, I will be having A times your 0 minus 2 squared plus B times 0 plus 3, 0 minus 2 plus C times 0 plus 3. Okay? So now, have I found A already? Yes, right? I have also found the value of C. Okay? So I just need to use the value of A and C that I've already found. And then replace it accordingly. Okay? Make use of your calculator to calculate the numbers out. We will be able to get here 8 minus 6b minus 3. So 5 minus 6b. And hence, -5 minus 5 equals to -6b. That is -18. And b is equals to -18 divided by -6. And we get 3. Okay? Just for you to copy down, okay, I will not scroll any further. I will be able to conclude that my answer will be equals to A, which is 2, B, which is 3, and then C, I found it to be -1. So, okay, I want us to see that what I've written over here. Okay, I have put there C to be -1, but can I simplify this part that I've highlighted yellow? Can, right? I should have written it as -1. Okay? Sorry, I think I need to clear this room already. You'll be penalized for simplification, no? Okay? So we get this as our answer. Okay? So go back home, go and try out question 1D. Right? Next lesson, your teacher will run it through with you. Okay? Thank you, everyone.